Hey everyone, ready to dive deep into AI today?
Always.
I bet you're here because, like a lot of our listeners, you're prepping for some serious AI interviews.
Yeah, those can be tough.
But we're about to make it a whole lot easier.
Love it.
We're breaking down a guide from Geeks for Geeks, that awesome website for all things tech.
Yeah, I've definitely spent some time on Geeks for Geeks.
It's their list of the top 50 AI interview questions. And let me tell you, it's packed with gold.
Oh, for sure. Those questions get right to the heart of it.
So consider this deep dive your secret weapon. We're covering everything, from the AI basics to some pretty advanced stuff.
Awesome. Let's get into it.
All right, so let's start with that million-dollar question. What exactly is artificial intelligence?
At its core, AI is all about building systems that can learn and adapt and solve problems. Things that usually we think of as requiring, human intelligence.
Right, it's not like traditional programming where you give the computer a set of instructions and that's it.
Exactly. It's about giving machines the ability to kind of figure things out on their own.
And they do that based on data and experience, right?
Exactly. Learning from the information they're exposed to.
Okay, so that brings us to this whole concept of learning. The guide mentions a bunch of different branches of AI, machine learning, NLP, even robotics, expert systems. It feels like AI is everywhere these days.
It really is, and all those branches just show how diverse AI is becoming. But for interviews, it's really key to understand how AI, machine learning ML, and deep learning DL all fit together.
Yeah, those terms get thrown around a lot, and it can be hard to keep them straight.
I totally get it. Think of them as like nested dolls.
Okay, I like that.
So AI is the biggest doll. It encompasses everything.
Right, the whole shebang.
Exactly. Then inside AI, you have ML, where algorithms can learn from data.
So ML is like a subset of AI.
Precisely. And then inside ML, you have DL, which is where those powerful neural networks come in.
So DL is like the brainiest of the bunch.
You could say that. It's
Yeah.
where things get really sophisticated.
Okay, so DL is a subset of ML, which is a subset of AI. I think I'm getting it now.
Awesome. It's all about levels of intelligence and complexity.
But this whole idea of machines learning, it kind of freaks some people out. Are we talking like robot uprising here? What about strong AI versus weak AI?
Okay, first, let's calm those fears. The robot takeover is pure Hollywood, at least for now.
I was going to say I haven't stocked up on robot fighting gear just yet.
You're probably good on that front. The AI we're dealing with today is mostly weak AI, meaning it's designed for specific tasks, very focused.
Okay, so like what kind of stuff are we talking about? Give me some examples.
Think about those recommendations you get while you're shopping online, or the spam filter saving your inbox from disaster. That's weak AI doing its thing.
Oh, right. That makes sense. So it's not like those super intelligent robots you see in movies taking over the world.
No, not yet at least. That's more in the realm of strong AI, also called artificial general intelligence, and that's a whole other conversation.
A conversation for another time, maybe. But I did notice the guide also mentions symbolic AI and connectionist AI. Are those like two completely different schools of thought?
You're absolutely right. They are two different ways of thinking about AI. So symbolic AI, sometimes called good old-fashioned AI, revolves around logic and rules. It's like a computer program packed with if-then statements.
So it's very structured and predictable.
Exactly. But connectionist AI takes a cue from our brains. It's all about neural networks, those interconnected webs of nodes. Connectionist AI learns by kind of tweaking the connections or weights between those nodes.
So it's less about following rules and more about learning from patterns, really.
Got it. It's like teaching a computer to think more intuitively, like we do.
Okay, that's pretty cool. But how does all this help me nail those interview questions?
Well, understanding these different approaches shows you get the fundamental differences in how AI systems work. You can even use this knowledge to tackle specific questions. For instance, they might ask about parametric versus non-parametric models.
Okay, I've heard those terms before, but I always get them mixed up.
Well, parametric models, like linear regression, make assumptions about the data.
So it's kind of like symbolic AI, relying on predefined rules.
Exactly. Non-parametric models, though, are more flexible, kind of like those neural networks in connectionist AI.
Ah, so they can adapt more easily to different types of data.
You got it. So knowing the bigger picture helps you connect the dots.
I see. It's like having a framework to understand all these different concepts.
Exactly. It gives you a solid foundation to build on.
Okay, that makes a lot of sense. Speaking of building, the guide also delves into overfitting, which sounds like a major construction hazard in AI.
Oh, it definitely can be. Overfitting is basically when your model gets a little too cozy with the data it's trained on.
Like it memorizes the answers instead of truly understanding the material.
It's exactly like that. Becomes a master of the training data, but then when it encounters new data, it's totally lost.
Oof, that sounds like a recipe for disaster.
Yeah.
So how do you prevent this overachieving gone wrong situation? The guide mentions cross-validation and regularization. Do those ring a bell?
Oh, yeah, for sure. Those are essential tools in the AI toolkit. Think of cross-validation like giving your model practice tests before the real deal.
So you're testing it on different subsets of data to see how well it generalizes.
Exactly. You want to see how well it performs on data it's never seen before. Regularization, on the other hand, is all about keeping things simple.
So it's like telling the model, hey, don't overthink it.
Yeah, it prevents the model from getting too fixated on those tiny details in the training data.
Okay, so cross-validation is like testing its ability to generalize. And regularization is like preventing it from getting too hung up on the specifics.
Precisely. It's all about finding that sweet spot, a model that's complex enough to learn, but not so complex that it just memorizes.
Got it. Makes sense.
Yeah.
The guide also throws in some other techniques like dropout and data augmentation. Those sound a bit counterintuitive.
Yeah, they might sound strange at first, but they work surprisingly well.
Okay, I'm intrigued. Tell me more.
So dropout is like randomly silencing parts of the neural network during training.
Wait, you're intentionally making parts of the network forget information.
In a way, yes. It forces the network to learn more robust features that aren't reliant on any single part.
So it's like making the network more adaptable and less prone to just memorizing.
Exactly. And data augmentation is all about getting creative with the data you already have. It's like stretching, rotating, cropping images just to create more training examples.
So you're basically giving the model more diverse experiences to learn from.
Exactly. It makes it more resilient to variations it might encounter in the real world.
Okay, I'm starting to see the logic here. But who or what is actually doing all this learning? The guide mentions these AI agents, which sound very sci-fi.
I know, right? But AI agents are basically a way to represent the part of the system that's making decisions.
So it's like the brains of the operation.
Yeah, you could say that. And the guide outlines different types of agents, each with increasing complexity.
Okay, so like a hierarchy of AI smarts.
Exactly. You start with simple reflex agents, just reacting to their immediate environment. Then you have model-based agents, which have some memory of past experiences.
So they can learn from their past mistakes.
Yes. Then there are goal-based agents, which can actually plan ahead to achieve objectives. And finally, you have the rockstar's learning agents. They adapt and improve over time.
Wow, so they're like the ultimate learners, constantly evolving and getting better.
Exactly. It's a pretty amazing progression.
It is. And knowing these different types of agents is definitely going to impress in an interview. It shows you really understand how AI systems work. But speaking of smarts, I'm curious about this whole concept of rational agents. What does it even mean for a machine to be rational?
That's a great question, and it's one that often comes up in discussions about AI.
Are we talking like Spock-level logic here?
Not quite. Rationality in AI is more about maximizing expected outcomes, making the best decision based on the available information.
So it's about making smart choices based on data and goals.
Exactly. Imagine playing chess. You analyze the board, you predict your opponent's moves, and you pick the move that's most likely to lead to victory.
Right, it's all about strategy and calculated moves.
That's a rational approach, and it applies to AI agents as well. They're designed to make choices that maximize their chances of success based on what they know and what they're trying to achieve.
So it's not about emotions or, feelings. It's about optimal decision-making based on data and goals.
Precisely. It's about being strategic and efficient.
Okay, I think I'm getting it now. And this whole idea of rationality ties into the famous Turing test, right?
Right.
That's the test where a machine tries to convince a human that it's also human through conversation.
That's the one. The Turing test is a fascinating benchmark in AI, although it's not without its critics.
Yeah, I can see how it might be a bit controversial. What are some of the arguments against it?
Well, some argue that passing the Turing test might simply demonstrate a machine's ability to mimic human conversation, not necessarily true understanding or intelligence. Think of those chatbots that can hold a conversation but don't really get what they're saying.
Oh, right, like those parrots that can repeat phrases but don't actually understand the meaning.
Exactly. It's impressive, but it's not quite the same as genuine intelligence.
So while the Turing test is an interesting thought experiment, It's not the be-all and end-all of measuring AI.
Agreed. It's just one piece of the puzzle.
Speaking of puzzles, the guide also dives into search algorithms, which seem to be a big part of AI problem solving. Why are they so important?
Search algorithms are essential because a lot of times finding the right answer in AI involves navigating a huge space of possibilities.
So it's like searching for a needle in a haystack, but on a massive scale.
Exactly. Search algorithms provide a systematic way to explore those possibilities and zero in on the optimal solution.
Okay, so it's not just about finding AI solution. It's about finding the best one and doing it efficiently.
Precisely. And the guide highlights two main types of search: uninformed search and informed search.
Okay, I'm guessing uninformed search is the less efficient approach.
You could say that. Uninformed search is like exploring a maze blindfolded. You just try every path until you stumble upon the exit. It's systematic, but it can be incredibly time-consuming.
Yeah, that doesn't sound very efficient. Informed search must be the smarter way to go.
Exactly. Informed search uses heuristics, which are like shortcuts or rules of thumb that guide the search toward the goal. It's like having a map of the maze, highlighting areas that are more likely to lead to the exit.
Ah, so it's like having a little bit of extra knowledge to guide your search.
Precisely. Heuristics can dramatically speed up the search process.
But I imagine they can also lead you astray sometimes, right? Like, what if the shortcut turns out to be a dead end?
That's true. Heuristics are estimates, not guarantees. Sometimes they might point you in the wrong direction or lead you to a decent solution, but not the absolute best one.
So it's like taking a shortcut that saves you time, but you might miss some interesting sights along the way.
Exactly. There's always a trade-off.
Makes sense. And the guide mentions some specific search algorithms. Breadth-first search, depth-first search, and there's one that always seems to come up, A.
A is a classic. It's a very popular algorithm for a reason.
So what makes it so special?
A combines the power of both cost and heuristics. Imagine you're navigating a maze, but this time you have a map, A and D, a compass. The map tells you the actual distances between points, and the compass guides you in the general direction of the exit.
So it's like having the best of both worlds, accurate information about the terrain, intuitive guidance towards the goal.
Exactly. And by combining these two sources of information, A can often find the shortest path very efficiently.
That's really clever. It sounds like A is a master navigator for AI problems. But shifting gears a bit, we humans learn a lot through trial and error. Is there a way to train AI systems in a similar way? I think the guide mentioned something called reinforcement learning for this.
You're right. It's called reinforcement learning, or RL. And it's all about training AI agents by letting them interact with their environment and learn from the consequences of their actions.
So it's like giving the AI agent a chance to experiment and learn from its mistakes, just like we do.
Exactly. It's a very powerful approach for situations where it's difficult to explicitly program the desired behavior.
So instead of telling the AI exactly what to do, you're setting up a system where it can learn by doing.
Precisely. You define the goals, you provide rewards for good behavior, and you let the agent figure out the best way to achieve those goals.
It's like training a dog. You reward the good behaviors, and hopefully the dog learns to do more of those things.
That's a great analogy, and it highlights the core principle of RL learning through feedback.
The guide mentions a bunch of key elements of RL. The agent, the environment, states, actions, rewards, policies. Can you break those down for us?
Sure. So let's imagine we're teaching a robot to play a video game. The robot is the agent.
Okay, the one making the decisions.
Right. The video game itself is the environment the agent is interacting with.
The world it's operating in?
Exactly.
Yeah.
The different screens or scenarios in the game represent the states. So each state is a different situation the agent might find itself in.
Okay, got it. What about actions?
The actions are the things the agent can do in each state. So in our video game example, the actions would be the buttons the robot can press.
Makes sense. And the rewards, those are like the points the robot scores, right?
Exactly. The rewards provide feedback to the agent, telling it whether it's doing well or not. And finally, the policy is the overall strategy the agent uses to make decisions. It's like the game plan the robot follows.
So the policy is what determines which actions the robot takes in each state, based on the rewards it's trying to maximize.
Precisely. It's the decision-making engine of the agent.
Okay, I think I'm starting to get the hang of RL. It's a pretty fascinating way to train AI systems.
It really is, and it's being used in a lot of cool applications, from robotics and gaming to finance and healthcare.
It sounds like RL has a lot of potential. But the guide also mentioned something called knowledge bases and expert systems. What are those all about?
Knowledge bases and expert systems are all about capturing human expertise and making it available in a way that computers can use.
So it's like creating a digital library of expert knowledge.
Exactly. A knowledge base is like a structured collection of information about a specific domain.
Okay, so like a database of all the knowledge a human expert has about a particular topic.
Precisely. And expert systems use that knowledge to answer questions, offer advice, or even solve problems.
So it's like having a team of experts on call, ready to answer any question you throw at them.
That's a great way to put it. And expert systems have been around for a while. They've been used in fields like medical diagnosis, financial analysis, and technical support.
Oh, so they're already being used in some pretty important areas. But could an expert system ever actually replace a doctor or a lawyer, for example?
That's a question that comes up a lot, and it's important to remember that expert systems are tools to assist human experts, not replace them.
Okay, so they're more like super smart assistants augmenting human capabilities.
Exactly. They can provide valuable insights and recommendations, but they still rely on human judgment and interpretation in many situations.
Makes sense. It sounds like AI is really good at tasks with clear rules and patterns, but it still struggles with things that require more nuanced human understanding.
You've hit the nail on the head. That's a major challenge in AI research, how to create machines that not only process information, but also understand it in a more human-like way.
Right, like how to teach a machine to understand emotions, empathy, or even just common sense.
Exactly. Those are areas where AI still has a lot of room for improvement. But even with those challenges, AI is already having a huge impact on our lives.
It definitely feels like we're just at the beginning of the AI revolution. And it's kind of mind-blowing to think about all the possibilities, both good and bad.
It is, and it's important to have these conversations to think about the ethical implications of AI and how we can ensure it's used for good.
Absolutely. We need to be mindful of the potential consequences as we develop these increasingly powerful technologies.
Agreed. It's a responsibility we all share.
Speaking of pushing boundaries, the guide also mentions some pretty advanced topics.
Mm.
Q-learning, SARSA, minimax algorithms, even Markov decision processes. I'm not going to lie, some of this stuff makes my head spin.
Don't worry, it's perfectly normal to feel a bit overwhelmed by these advanced concepts. The key is to grasp the main idea behind each one and be able to explain it in simple terms.
Okay, so it's more about showing that you can learn quickly and grasp the essential concepts, even if you're not an expert on every algorithm under the sun.
Exactly. And if you can connect those concepts to real-world applications or examples, even better.
Right, because ultimately it's about showing that you can use these concepts to solve real problems.
That's the key. It's about applying your knowledge, not just memorizing it.
So if they ask me about, say, Q-learning or SARSA, I don't need to know all the nitty-gritty mathematical details, but I should be able to explain the general idea behind them and maybe give an example of how they're used.
Exactly. For instance, Q-learning and SARSA are both approaches to learning and reinforcement learning. They both involve an agent interacting with an environment and learning from its experiences, but they differ in how they update their knowledge based on those experiences.
So they're like two different learning styles for AI agents.
You got it. Each with its own strengths and weaknesses.
Makes sense. And what about that minimax algorithm? That one sounds kind of ominous.
It might sound intimidating, but it's actually a pretty classic algorithm for decision-making in competitive games like chess. It's all about anticipating your opponent's moves and choosing the move that gives you the best chance of winning, even if your opponent plays perfectly.
So it's like a battle of wits between two AI agents
Hmm.
trying to outmaneuver each other.
That's a great way to think about it. It's all about strategy and optimization.
Okay, so minimax is all about finding the best move in a competitive situation, assuming your opponent is also playing optimally.
Exactly. It's a powerful technique for games and other adversarial scenarios.
And then there are those Markov decision processes, or MDPs. Those sound pretty abstract.
They are a bit more abstract, but they're essentially a mathematical framework for modeling decision-making under uncertainty. They provide a way to represent sequential decision-making problems where the outcome of each decision depends on both the current state and the actions taken.
So they're a way to model real-world situations where there's an element of chance involved.
Precisely. And they've been applied in a wide range of fields, from
Yeah.
robotics to finance to healthcare.
It's amazing how these seemingly abstract concepts have such far-reaching applications.
It really is. And it just highlights the power and versatility of AI.
But before we get too lost in the theoretical weeds, let's bring things back down to earth and talk about a topic that's been generating a lot of buzz lately: generative AI.
Oh, generative AI, it's definitely the hot topic of the moment.
It seems like it's everywhere these days. What exactly is it all about?
Generative AI is all about creating new content, whether it's text, images, music, or even code. It's powered by those deep learning models we talked about earlier, especially those complex neural networks.
So instead of just processing existing data, generative AI is about creating something entirely new.
Exactly. It's about machines becoming creators, not just consumers of information.
That's pretty incredible. And there are a bunch of different architectures being used in generative AI, right? Like GANs, VAEs, and those transformer models we talked about earlier.
You got it. Transformer models are particularly good at understanding and generating text. So they're a natural fit for tasks like machine translation, text summarization, and even chatbot development.
Right. They're the ones that can write poems, compose music, and even generate code, which is mind-blowing.
They're definitely pushing the boundaries of what's possible with AI.
And what about GANs and VAEs? What makes them unique?
GANs, or generative adversarial networks, are like two neural networks locked in a creative duel.
Okay, this sounds interesting.
One network, the generator, tries to create realistic data. The other network, the discriminator, tries to tell the difference between real and fake data.
So it's like a constant back and forth, with each network trying to outdo the other.
Exactly. And this competition actually drives both networks to improve.
It's like they're pushing each other to be more creative and more realistic.
Precisely. It's a very clever approach, and it's led to some pretty remarkable results.
That's really cool. And what about VAEs? How do they work their magic?
VAEs, or variational autoencoders, are a bit more technical, but essentially they learn compressed representations of data and then use those representations to generate new similar data.
Okay, so it's like they're learning the essence of something and then using that knowledge to create variations on a theme.
Exactly. It's like learning the style of a particular artist and then using that style to create new works of art.
That's pretty incredible. It sounds like generative AI is really pushing the boundaries of what's possible with AI.
It definitely is. And it's an area that's evolving rapidly, so who knows what amazing things we'll see in the future.
I'm excited to find out. But before we get too carried away with the future of AI, let's make sure we tie all this back to those interview questions we started with.
Good point. Let's bring it back to the practical side of things.
So we've covered a lot of ground, from basic AI concepts to those mind-boggling advanced algorithms. What are the key takeaways for someone prepping for an AI interview?
Well, first of all, don't get overwhelmed by the sheer volume of information out there. The goal isn't to memorize every single algorithm or technique.
Right, it's more about understanding the fundamental concepts and being able to apply them.
Exactly. Focus on building a solid foundation of knowledge, and then you can use that foundation to tackle specific questions and challenges.
So if they ask me about a specific algorithm that I'm not super familiar with, what's the best approach?
Stay calm and think it through. Start by explaining the broader concept the algorithm falls under. For example, if they ask about a specific type of neural network, talk about the general principles of neural networks. First, how they learn, how they adjust weights, how they make predictions.
Right, so start with the big picture and then try to connect the specific algorithm to those broader concepts.
Exactly. Even if you don't know the nitty-gritty details of that particular algorithm, you can still demonstrate your understanding of the underlying principles.
That's a great strategy. It's like showing that you can see the forest for the trees.
Exactly. And don't be afraid to admit if you don't know something. It's better to be honest than to try to bluff your way through it.
Yeah, honesty and humility go a long way, especially in a field like AI, where there's always so much to learn.
Absolutely. And remember, interviewers aren't just assessing your technical knowledge, they're also looking at your problem-solving skills, your communication abilities, and your overall enthusiasm for AI.
So it's about showing that you're a well-rounded individual who can not only handle the technical challenges, but also collaborate effectively and communicate your ideas clearly.
Precisely. AI projects are rarely solo endeavors. They often involve teams of people working together to solve complex problems.
That's true. It's a very collaborative field.
Exactly. So being able to communicate your ideas, explain technical concepts to non-technical audiences, and work well with others is essential.
Makes sense. So along with brushing up on your technical knowledge, it's also important to practice your communication and collaboration skills.
Absolutely. And don't underestimate the importance of showcasing your passion for AI. Let your enthusiasm shine through. Talk about projects you've worked on, areas of AI that particularly excite you, or even just your overall fascination with the field.
Right, because passion is contagious. If you're genuinely excited about AI, it will show.
Exactly. And remember, interviews are a two-way street. It's not just about them assessing you, it's also an opportunity for you to assess them and the company culture. Oh.
Oh, that's a good point. It's about finding the right fit, both technically and culturally.
Precisely. Ask questions, engage in conversation, and get a sense of whether this is a place where you can see yourself thriving.
Great advice. So, to everyone listening who's gearing up for AI interviews, remember, brush up on your technical knowledge, practice your communication skills, showcase your passion, and don't be afraid to ask questions.
Exactly. And most importantly, believe in yourself.
You got this. And remember, this deep dive was inspired by that awesome guide from Geeks for Geeks on the top 50 AI interview questions. It's a fantastic resource, so definitely check it out.
It's packed with valuable insights and practice questions.
Absolutely. So to everyone listening, we wish you the best of luck on your AI interview journey. May your algorithms be efficient, your models be accurate, and your enthusiasm be contagious. Until next time, keep diving deep into the incredible world of AI.
Happy learning. So, as we delve deeper into these, AI agents, these complex AI agents, it makes you wonder, what does it even mean for a machine to be rational?
Yeah, that's a great point. The guide keeps mentioning these rational agents, but is it really like Spock from Star Trek? All logic, no emotion?
Haha. Well, not exactly. It's not about, suppressing all emotions or anything like that. Rationality in AI, it's more about making the best choice possible given the information it has.
So it's not about feelings. It's about making the smart move, kind of like a chess grandmaster analyzing all the possible plays.
That's a great way to think about it. A rational AI agent, it's all about strategy and optimization, making choices that, increases chances of success, reaching that goal.
That makes sense. It kind of reminds me of that whole concept of the Turing test. Does that tie into this at all?
Absolutely, the Turing test. Yeah, that's where a machine, tries to convince a human that it's human as well,
Right.
right? Through conversation.
Right, exactly.
That's that classic test in AI. Although it does have some controversy around it.
Yeah, I can imagine it's a tricky concept for sure. Like, what are
Ah.
the arguments against it?
Well, some folks argue that, passing the Turing test, what it really demonstrates is the machine's ability to mimic human conversation, not necessarily true understanding.
Right? It's like one of those chatbots. They can hold a conversation, but they don't really get it, do they?
Exactly. They're just really good at mimicking like a parrot repeating phrases,
Yeah, entertaining, but not necessarily deep thinking going on there.
Exactly. So, while the Turing test is interesting to think about, it's not like the ultimate measure of AI's progress.
Okay, I get it. So passing the Turing test might be a neat trick, but doesn't mean an AI is actually, thinking like us.
Right, right. There's more to it than that.
Speaking of smarts, the guide,
Mhm.
it spends a lot of time on these search algorithms. Why are those so crucial in AI?
Search algorithms, they're the tools that AI agents use, to find solutions because a lot of AI problems, they involve sorting through tons and tons of possibilities.
Like finding the best route on a map with a gazillion roads, or picking the perfect move in a game with, like, infinite variations.
Exactly. Search algorithms give us a way to explore those possibilities in a systematic way and, find the best solution, not just any solution.
Oh, so it's about strategy and efficiency, not just stumbling upon something that works.
Absolutely. And the guide talks about two main types of search: uninformed search and informed search.
Okay, uninformed search. That sounds like the less efficient way to go.
You could say that. Uninformed search is like, wandering through a maze blindfolded, just trying every path until you randomly find the exit. It works, but it could take forever.
Yikes, I can imagine. There's got to be a smarter way.
There is, and that's where informed search comes in. Informed search uses heuristics, which are basically shortcuts or rules of thumb, to help guide the search toward the goal.
Ah, so it's like having a GPS suggesting the best routes based on, traffic and distance.
Exactly. It
Yeah.
can make the search process much faster and more efficient.
But heuristics, I mean, they're just estimates, right? They can't be perfect all the time.
That's true. They can sometimes lead you astray. You might end up with a good solution, but not necessarily the absolute best one.
It's like taking a shortcut that saves you time, but you miss out on some of the scenery along the way.
Exactly. There's always that trade-off to consider.
Makes sense. And the guide, it throws in some specific search algorithms, breadth first, depth first. And then there's A, which always seems to be a favorite.
Hey, yeah, that's a classic algorithm. It's very popular for a good reason.
So what makes A so special? What sets it apart?
It combines the power of cost and heuristics. It's kind of like navigating a maze. but you've got a map and a compass. The map gives you the actual distances, and the compass, that's like your heuristic, it guides you in the right general direction.
So you've got the precise measurements and then this kind of intuitive sense of where to go.
Exactly. And by using both, A can often find the shortest path super quickly.
That's amazing. Like a master navigator for AI problems, really clever.
It is, and it's used a lot in, robotics, pathfinding, game playing, all those areas where finding the best solution fast is really important.
Makes sense. But, we humans, we learn a lot through trial and error, just trying things out and seeing what works.
Mm.
Is there an AI equivalent for that? I think the guide mentioned something about reinforcement learning.
Oh, yeah, absolutely. Reinforcement learning, or RL, it's all about letting those AI agents interact with their environment and learn from the consequences of their actions.
So it's like giving them a space to experiment and learn from their mistakes, just like we do in the real world.
Exactly. It's really effective in situations where it's hard to, program the exact behavior you want.
So instead of giving the AI a step-by-step guide, you're kind of setting up a system where it can learn through experience,
Precisely. You define the goals, the rewards, and you let the agent figure out the best path to get there.
It's like treating a dog.
Yeah.
You reward the good behavior, and hopefully it learns to repeat those actions, right?
That's a great analogy. It highlights that core idea of learning through feedback, which is at the heart of RL.
The guide mentions all these elements of RL, the agent, the environment, states, actions, rewards, policies. It sounds pretty complex. Can you break those down for us?
Sure, no problem. Let's stick with that idea of teaching a robot to play a video game. So the robot is the agent, right?
Okay, that's the one making the decisions.
Right. The video game itself, that's the environment that the agent's operating in.
So the world that it's interacting with.
Exactly. And the different screens or scenarios in that game, those represent the states.
Okay, each state is like a different situation.
Right. Each state is a different situation that the agent might encounter.
Got it. What about actions?
The actions those are the things the agent can do in each state. So for our robot playing the video game, the actions would be the buttons it can press on the controller.
Okay, that makes sense. And the rewards. I'm guessing those are the points the robot scores.
You got it. The rewards tell the agent whether it's doing well or not, giving it that feedback.
Right, like positive reinforcement for good moves
Yeah.
and maybe penalties for bad ones.
Exactly. And then finally, you have the policy. The policy is the overall strategy that the agent uses to make decisions, kind of like the game plan the robot follows.
So the policy determines which actions the robot takes in each state, based on the rewards it's trying to get.
You got it. It's the brains of the operation, you could say.
Okay, I think I'm starting to get a better grasp of RL now.
It's
It's a pretty clever way to train these systems.
It is, and it's being used for some amazing stuff these days, robots navigating difficult terrain, optimizing traffic flow in cities, even beating world champions at games like Go and chess.
Wow, that's impressive. It sounds like RL has a ton of potential.
Yeah, it really does. It's an exciting area of AI research.
But the guide also mentions these things called knowledge bases and expert systems. What are those all about?
Those are all about taking human expertise and putting it into a form that computers can use.
So it's like building a digital library of expert knowledge.
Exactly. It's a structured collection of information about a specific domain, like a giant encyclopedia of knowledge curated by experts.
Okay, so it's like all the knowledge that a human expert has about a specific field, but organized and digitized.
Exactly. And then an expert system, it uses that knowledge base to answer questions, offer advice, or even solve problems.
So it's like having access to a team of specialists on demand, ready to help you with whatever you need.
That's a great way to put it. They've been used in things like medical diagnosis, helping doctors make decisions.
Oh, wow. So they're already being used in some pretty serious fields.
Yeah, they have a lot of potential. But, a common question is, could an expert system actually replace, say, a doctor or a lawyer completely?
Yeah, that's what I was wondering.
Well, it's important to remember that expert systems, they're really tools to assist human experts, not to replace them entirely.
Okay, so they're more like powerful assistants augmenting human capabilities.
Exactly. They can do a lot. They can provide insights, make recommendations, but they still rely on human judgment and experience in a lot of cases.
Makes sense. It seems like AI is great at tasks with clear rules and patterns, but those areas that require more nuanced human understanding, that's where it still struggles.
You're absolutely right. That's a big challenge for AI research, how to build machines that can understand the world in a more human way with all its complexity and ambiguity.
Right, like understanding emotions, empathy, things like that. That's tough to program.
It is. But even with those challenges, AI is making incredible progress.
Yeah, it feels like we're at the beginning of something really big here. It's exciting, but kind of scary too, to be honest.
I know what you mean. There are a lot of ethical considerations we need to think about as this technology advances.
Absolutely. It's a responsibility we all share to make sure AI is used for good.
I agree. It's important to have those conversations and think about the potential impact of AI on society.
Right? We need to be mindful and proactive as we develop these powerful tools.
Absolutely. But even with those, big picture questions, let's not forget about those interview questions we started with.
Right, let's bring it back to the practical stuff. We've covered a lot of ground from the basics of AI to some pretty mind-bending advanced topics. What are some key takeaways for our listeners who are, prepping for AI interviews?
Don't get overwhelmed by the sheer volume of information out there. That's the first thing. You don't need to memorize every single algorithm.
Right, it's about understanding the core concept.
Exactly. Build a solid foundation of knowledge, and then you can apply that to specific questions and challenges.
So if I get a question about a specific algorithm that I'm not, totally familiar with, what's the best approach?
Stay calm, think it through, start with the broader concept that algorithm falls under. So, if they ask about a specific neural network, talk about neural networks in general first.
So start big picture, and then try to connect the dots to that specific algorithm.
Exactly. Even if you don't know all the details of that one algorithm, you can still show that you understand the underlying principles.
Right. It shows you can think critically and connect those concepts.
Exactly. And don't be afraid to admit that you don't know something. It's much better to be honest than to try to fake it.
Yeah, honesty and a willingness to learn, that goes a long way.
It really does. And remember, interviewers are looking at more than just your technical knowledge.
Right. They want to see how you think, how you communicate.
Exactly. How you approach problems, how you work with others. Because AI projects, they're rarely solo efforts.
Right. It's a collaborative field.
Absolutely. So being able to communicate your ideas clearly, work well with a team, those are really important skills.
Okay, so along with all that technical knowledge, practice those communication skills, teamwork skills. Those are key as well.
Absolutely. And don't forget to show your enthusiasm. Let your passion for AI shine through. Talk about projects you've worked on, areas that excite you. Passion is contagious.
All right, if you're genuinely excited about it, that'll come across in the interview.
Exactly. And remember, interviews are a two-way street. It's not just about them assessing you. It's a chance for you to get a feel for them, for the company culture.
Right, it's about finding that right fit,
Yeah,
both technically and in terms of the work environment.
exactly. Ask questions, engage in a conversation, see if you can picture yourself working there.
That's great advice. So to all our listeners out there prepping for AI interviews, remember, brush up on the technical stuff, practice those communication skills, show your passion, ask questions.
Yeah, and most importantly, believe in yourself.
You got this. And to help you prepare even more, don't forget to check out that guide from Geeks for Geeks, the one we've been talking about today.
Yeah, it's a fantastic resource, tons of great info and practice questions.
Absolutely. So to everyone listening, good luck on your AI interview journey. May your algorithms be efficient, your models be accurate, and your enthusiasm be contagious. We'll catch you in the next part of our deep dive. Okay, so let's shift gears a little bit here and get back into that interview prep mindset.
It sounds good.
I know we've covered a ton from the basics of AI all the way to some seriously complex stuff.
We have. It's been quite the journey.
But I want to make sure we, bring it all together and think about how you can use all this knowledge to really nail those AI interviews.
Absolutely. Let's make sure you're ready to impress those hiring managers.
Because that's what this deep dive is all about, right?
Yeah.
Giving you the tools and the confidence to ace those interviews.
That's right. Let's get you ready to shine.
So the guide we've been, dissecting here, it mentions all sorts of algorithms and techniques. Honestly, it can feel a bit overwhelming.
Oh, it definitely can be. The AI world is vast. There's so much out there.
So how do you even begin to prepare for all those potential questions?
Well, the first thing to remember is the goal isn't to memorize every single algorithm or equation.
Right. It's not about just spitting back facts and figures.
Exactly. It's about showing that you understand the core concepts, that you can think critically, and that you're genuinely passionate about AI.
So it's more about showing that you can learn, that you can adapt, and that you can apply your knowledge to real-world problems.
Precisely. Hiring managers, they're looking for people who can not only talk the talk, but also walk the walk.
They want to see how you approach challenges, how you break things down, how you connect the dots.
Exactly. They want to see your thought process, your problem-solving skills.
Okay, that makes sense. So let's say they hit you with a question about a specific algorithm that you're not, super familiar with. What's the best way to handle that?
Don't panic. That's the first thing. Take a breath, think clearly, and apply what you do know.
So even if you don't know the exact algorithm, you can still impress them with your overall understanding?
Absolutely. Start by explaining the broader concept. What category does that algorithm fall under? For instance, if they ask about a specific neural network, talk about neural networks in general first.
Right, like how they learn, how they make predictions, that kind of stuff.
Exactly. Connect those dots. Show them you understand the big picture, even if you don't have all the details on that one specific algorithm.
That's a great strategy. It's like showing them you can see the forest for the trees.
Precisely. And honestly, if you don't know something, just admit it. It's better to be upfront than to try to bluff your way through it.
Yeah, honesty and a willingness to learn, those are always good qualities to show in an interview.
Absolutely. And remember, interviewers aren't just evaluating your technical skills. They're also looking at your soft skills, your communication, your problem solving, your teamwork, all of that.
Right, because AI projects, they're not usually solo missions. It's all
Ugh.
about collaboration.
Exactly. So being able to communicate your ideas clearly, to explain technical concepts to non-technical people, to work effectively in a team, those are crucial skills.
So brush up on your technical knowledge, yes, but also practice those communication and collaboration skills.
Absolutely. And one more thing, don't be afraid to show your passion. Let your enthusiasm shine through. Talk about projects you've worked on, things that excite you about AI. Passion is contagious.
Right, it shows you're genuinely interested and invested in the field.
Exactly. And remember, interviews are a two-way street. It's not just about them evaluating you. It's also a chance for you to assess them, to see if the company culture is a good fit.
Oh, that's a good point. It's about finding the right environment where you can learn and grow.
Precisely. Ask questions, get a feel for the team, the projects, the overall vibe. See if it aligns with your goals and values.
That's great advice. So to everyone listening out there who's gearing up for AI interviews, remember, know your stuff, practice those communication skills, let your passion shine, and ask questions.
And most importantly, believe in yourself. You got this.
Exactly. And of course, don't forget to check out that amazing guide from Geeks for Geeks, the one we've been discussing today, the top 50 AI interview questions. It's a goldmine of information and practice questions.
Absolutely. It's a fantastic resource.
And that wraps up our deep dive into the world of AI interview prep. To everyone listening, we wish you the best of luck on your AI journey. May your algorithms be efficient, your models be accurate, and your enthusiasm be contagious. Keep learning, keep exploring, and until next time, happy AIing.